Today's topic is grouping of cells, and today's information about the great scientist, the inventor of lead acid battery and the inventor of rechargeable battery. Inventor of lead acid battery is WILHELM JOSEF SINSTEDEN, a German physician and physicist. Born on 6th May 1803, he constructed circuit breaker and one of the first electric motor. In the year 1854, he developed lead acid battery which operates 5 years. Died on 12th November 1891. The next is the inventor of rechargeable battery, GASTON PLANTÉ, French physicist, born on April 22, 1834 in France. In the year 1854, he began work as an assistant lecturer in physics at the Conservatory of Arts and Crafts in Paris. In the year 1859, he invented the lead acid cell, the first rechargeable battery. In the year 1860, he rose to the post of Professor of Physics at the Polytechnic Association for the Development of Popular Instructions. He died on 21st May 1889. In the year 1989, the Bulgarian Academy of Science established a GASTON PLANTÉ medal, which awarded every 2 years the scientist who made significant contribution to the development of lead acid battery technology. Now we will see the grouping of cells. A battery is a group of cells. Cells may be connected in series or in parallel or in series parallel, depends upon the requirement. First we will see, if a number of cells are connected in series, what is its total current and the circuit current, what is the voltage drop. Here the term E represents EMF of an individual cell. Therefore, and total EMF is equal to sum of the EMF of individual cells. Therefore, total EMF ET is equal to N into E. The term R represents the internal resistance of a cell. Each cell has some internal resistance. Here the cells are identical. Therefore, N into R. Therefore, total internal resistance is equal to N into R. I am connecting a load resistance capital R. Therefore, the total resistance in the circuit is equal to R plus N into R. Now I can easily find the total current. Total current is equal to, the circuit current is equal to N into E, the total EMF, divided by load resistance R plus N into R. Here, what is the voltage drop due to the internal resistance? That is that current into N into R, where R is the internal resistance. Therefore, the terminal voltage is equal to EMF, total EMF minus total voltage drop, E minus VR. This is the terminal voltage. Here, the EMF is always greater than the terminal voltage. If it is a 12 volt, we will get only a 11 volt because of the voltage drop due to the internal resistance. We can also find the internal resistance R is equal to terminal voltage minus EMF divided by total current I. The next is parallel. When the cells are connected in parallel, the voltage is constant. Suppose I am connecting 3 12 volt battery, the supply voltage is 12. The condition of paralleling is the EMF should be same. Whether it is a 6 volt or 12 volt or 1.5 volt, the voltage should be same. Next is the ampere or capacity should be same. The third is internal resistance of the batteries should be same. That is the basic conditions. If I am connecting n number of cells in parallel, where R is the internal resistance. When I am connecting two cells, therefore R1 into R2 divided by R1 plus R2. The cells, here the condition is R should be same. Then only we can connect in series or in parallel. Here, when R1 is equal to R2, I will get R square by 2R. Here the 2 is represent number of cells. I am connecting 2. If I connect n number of cells, therefore the total internal resistance RT is equal to R by N. Therefore, I is equal to, total circuit current is equal to E divided by R by N plus R, capital R. Capital R represents the load resistance. Now I can rewrite the formula. I is equal to N into E divided by R plus N into R. Simply you call in these two formulas. Here the IT is equal to N into E R plus N into R, where in the case of series. In parallel circuit, N into E small r plus N into capital R. The second thing is I have to find the voltage drop. What is the voltage drop? Circuit current into resistance. Here the total resistance is R by N. I into R by N. Here the terminal voltage V is equal to E minus V into R. Now in the series parallel combination, here 3 batteries or 3 cells are connected in series. How many rows? 4 rows. Total number of batteries 12. Here I am connecting n number of cells. Here m is represent number of rows. How many rows? 4 rows. Here in this circuit 4 rows. If m is equal to number of rows and n is equal to number of cells in each row, therefore total number of cells n is equal to capital N is equal to m into small n. The internal resistance is equal to R, small r, into n. N is the number of cells in each row. Therefore, internal resistance in each row is equal to N into R. Therefore, total resistance is equal to 1 by NR plus 1 by NR. So, if it is N, 1 by M by NR, simplify NR by M. That is the total internal resistance. N into R by M ohms. Therefore, I can find the current. I is equal to total EMF by R plus N into R by M, where R is the load resistance. I know that the total number of cells, a capital N is equal to M into N, where M is the number of rows. N is number of cells in each rows. Therefore, M is equal to capital N by small n. I simply substitute in the formula. I will get N into E divided by capital R plus N square into R by capital N, where N is the number of cells in each row, capital N is the total number of cells in the circuit, small r is the internal resistance, capital R is the load resistance. Therefore, the voltage drop is equal to load current into N into R by M. This is the formula already I found. This is the N into R by M. Now we will work out some problems. Problem 1. A battery consists of 8 cells, each having an EMF of 1.5 volts and internal resistance of 0.4 ohms joined in series. If this battery supplies current to a 10 ohm resistor, calculate A. The current supplied by the battery, B. The potential across the battery terminals. In this problem, number of cells is given, that N is equal to 8, and individual cell EMF is given, that is 1.5 volts, and internal resistance is given 0.4 ohms, and load resistance R is given, R is equal to 10 ohms. All the values are given. Now the total EMF is equal to 8 into 1.5, that is equal to 12 volts. Total internal resistance is equal to 8 into 0.4, that is equal to 3.2 ohms. Total circuit resistance is, that is given, that is 10 plus 3.2, 13.2 ohms. So I can easily find the current. 12 divided by 13.2, I will get 0.909, or I can use this formula. Current supplied by the battery is equal to N into E divided by R plus N into R. I substitute in the formula, I will get the same result, 0.909 amps. Therefore, I can find the voltage drop once I know the current. I into N into R. I substitute in the formula, N is given, R is given. The voltage drop is 2.909 volts. Therefore, the terminal voltage is equal to the total EMF of the battery, 12 minus 2.909, is equal to 9.091 volts. Part A is over, this is part B. Here I will, instead of 10 ohm, I will connect 3.2 ohm. What will happen? If I will connect 3.2, the total resistance will become 6.4. Now the current will become 1.875. The voltage drop is equal to 6 volts. 50% drop. Total voltage is 12. Total EMF of the battery is 12. Now I will get a voltage only 6 volts. Next step is, I will connect a resistance 5 times the internal resistance. Here the internal resistance 3.2 into 5 is equal to 16 ohms. Therefore total resistance is equal to 19.2. Therefore I is equal to 0.625 amps. Now I will calculate the power dissipation, I square R. For a 10 ohm resistor, the power is 8.27 watts. For 3.2 ohms, that is equal to the internal resistance, I will get 11.25 watts. Then 5 times the internal resistance, 16 ohms I connected, I found the power is 6.25 watts. I will get a maximum power when the load resistance is equal to the internal resistance of the battery. I will get 11.25 watts. The second problem, here 6 cells of 1.5 volts EMF and 0.5 ohm internal resistance each are connected in parallel. The resistance of the load resistor is 10 ohms. Calculate the circuit current, voltage drop and terminal voltage. In this problem, number of cells is given, 6 cells, all are connected in parallel. Each cell EMF is given 1.5 volts. The internal resistance is given 0.5 ohms. Load resistance is 10 ohms. I have to calculate what is the total current, total voltage drop and the terminal voltage. Here the EMF is 1.5. All are connected in parallel. Therefore, the terminal voltage is always less than the EMF. This voltage 1.5, less than 1.5. First I have calculated the current I. I is equal to N into E divided by R, small r plus N into R. It's the formula already we have derived. Therefore, simply I substitute in the formula, I find the current is equal to 0.149 amps. This is the step 1 is. The question 1 is answered 0.149. Number 2, I have to find what is the total voltage drop. Total voltage drop is equal to I into R by N. So I know the current 0.149 into 0.5 internal resistance of the battery divided by N is equal to 6. 0.012 volts. Therefore terminal voltage is equal to 1.5 minus 0.012 is equal to 1.488 volts terminal voltage. This is 2, this is 3. I can check P is equal to I into R. The terminal voltage is 1.49. Here I is equal to 0.149. The load resistance is 10. That is equal to 1.49. The problem is correct. Instead of 10 ohms, I put what is the internal resistance? 0.5 ohms. I put 0.5. Now I have calculated the current. I is equal to N into E divided by R plus N into capital R. I substitute in the formula. I is equal to 2.57 amps. I have found the voltage drop. Voltage drop will become 0.214. Therefore terminal voltage is 1.286 volts. When the load resistance is 10, the terminal voltage is 1.488 volts. When the load resistance is 0.5, the terminal voltage is 1.286. When the load resistance is 10, the power is 0.22 watts. And the load resistance equal to the internal resistance 0.5. In this case, the power is 3.3 watts. Problem 3. A battery comprises of 6 cells, each with an EMF of 2 volts and internal resistance of 0.02 ohms. Calculate the power consumed in an external circuit of resistance 0.25 ohms when the cells are connected A. all in series, B. all in parallel. In this problem, number of cells is given 6. A battery comprises of 6 cells. and each cell EMF is given 2 volts and resistance, internal resistance is given 0.02 ohms and load resistance is given 0.25 ohms. We have to find power consumed in external resistance, that is 0.25 ohms, when cells are connected in parallel and in series. If the cells are connected in parallel, what will be the power consumption? The cells are connected in series, what is the power consumption? That is what we have to find. First we have to find cells are connected in series. We know the formula I is equal to N into E divided by capital R plus N into small r. The R is the load resistance and small r is the internal resistance. We simply substitute in the formula. The current is 32.43 amps. Therefore, power dissipation or power consumption is equal to I square into R. That is 32.43 the whole square into 0.25. 262.93 watts. And we can also find what is the voltage drop. We know the formula I into N into R. Here I is 32.43, N is 6 and internal resistance is 0.02. Substitute, we will get 3.89 volts. Therefore, the total voltage is 6 into 2, 12 volts. 12 minus 3.89 will get 8.11 volts. Its terminal voltage is 8.11. Total voltage drop is 3.89. Power consumption is 262.93 watts. Now the cells are connected in parallel. All the cells are connected in parallel. The formula is I is equal to N into E divided by small r E plus N into capital R. A small r represents internal resistance, capital R represents load resistance. Simply substituting the formula, we will get a current of 7.89 amps. The power consumption is equal to I square into R, 7.89 the whole square into 0.25, 15.56 watts. And we can also calculate the total voltage drop, that is I into R divided by N formula. The I is, we know that 15.56 into 0.02 divided by 6, we will get 0.052. Here the terminal voltage, here the voltage is EMF voltage is 2, here all are connected in parallel. 2 minus 0.052, 1.948 volts, that is the terminal voltage is 1.948 and the total voltage drop is 0.052, power consumed is 15.56 watts. Problem number 4. A battery consists of 20 cells, each of EMF 2 volts and internal resistance 0.2 ohms. Connected 5 in series per row, 4 rows in parallel. If this battery is connected to an external resistance of 1.2 ohms, how much current will it supply and what is its terminal voltage and total voltage drop? In the fourth problem, 20 cells are connected as shown in figure. That is 5 in series per row. There are 4 rows. In each row 5 cells are contained. Each cell EMF is given 2 volts and load resistance is given 1.25 ohms and the internal resistance of each cell is given 0.2 ohms. Now we have to find the total resistance. Here N is equal to, capital N is equal to total number of cells. Small n is equal to number of cells per row. Here N is equal to 5. There are 1, 2, 3, 4, 5 and 5 into 4 is equal to 20. Therefore N is equal to 5. Total resistance of the circuit is equal to capital R plus N into R divided by M. M represents rows. Simply substitute in the formula, you will get 1.5 ohms. Total resistance in the circuit is 1.5 ohms. Therefore total EMF is equal to N into E. Because here 5 cells are in series. Therefore N is 5 into E, each cell EMF is 2 volts given, therefore 10 volts. Therefore current supplied by the battery is equal to, total current IT is equal to total EMF divided by total resistance, 10 divided by 1.5, that is equal to 6.67 amps. Therefore voltage drop is equal to I into N into R divided by M. Here we know all I value 6.67, N is equal to 5, R is equal to 0.2, M is equal to 4. The voltage drop, total voltage drop is equal to 1.67. Therefore, the terminal voltage is equal to total EMF 10 minus 1.67, we get 8.33 volts. The fifth problem is a battery is made from 48 cells, each of 2 volts EMF and 0.2 ohm internal resistance. A resistance of 5 ohm is externally connected to the battery. How should the cells are arranged in order to obtain maximum current in the circuit? Find the value of maximum current. In the fifth problem, the given values are, number of cells is given 48. EMF of each cell is given 2 volts. Internal resistance of each cell is given 0.2 ohms. Load resistance is given 5 ohms. Our aim is to find the maximum current as well as in each row how many cells we can accommodate to obtain a maximum current. That is the question. M into N is equal to 48. M represents number of rows. N is equal to number of cells in each row. Normally, therefore, capital N is equal to M into N. For obtaining maximum current, M into R is equal to N into R. M into load resistance is equal to number of cells in each row into resistance, that is internal resistance R. Therefore, M into 5 is equal to 0.2 into N. Therefore, N is equal to 25 M. Since M into N is equal to 48, therefore M square into 25 is equal to 48. Therefore, M is equal to 1.386. The nearest value is 2. Therefore, the number of rows should be 2. Once I know the number of rows, I can easily find how many cells in each row. N is equal to 48 by 2. That is nothing but here I know the value of M, that is 2. N is equal to 48 by 2. That is the thing, the 24. So each row contains 24 cells. There are 2 rows. Total number is 48. 2 into 24 is equal to 48 cells. Now I have to find the maximum current I. Current through the circuit. I is equal to N into E divided by R plus N into R by M. M is the row, N is the number of cells, E is the EMF of each cell. I simply substitute in the formula, I will find I is equal to 6.49 amps. So if the 48 cells are arranged in 2 rows, each row contains 24 cells, it gives a maximum current of 6.49 amps. With this I conclude my lecture. Thanks for listening.